Hi everyone, Jax here from Navaflow. Today I'm going to be showing you how to set up and launch a simulation with AeroCloud, our tool for automated online-based wind simulations on models of any kind for external aerodynamics. As I said, AeroCloud is the tool that we're going to be using, which can be used by designers or engineers. It doesn't require any background in aerospace engineering or aerodynamics in general to be able to launch a simulation, and it can be used on any kind of geometry where external aerodynamics matter, and in some cases also for internal aerodynamics and fluid dynamics. So let me jump to the account. I have an account created. I want to launch a simulation. I need to first create a project that in my case it's demo simulations, and then I can click on create a new simulation. Here the only thing I need to do now is upload a geometry that I'm interested in testing out. There is a limit of 1 gigabyte for models, but most of the time you need way less. In this case 300 megabytes is quite a heavy model. I could have simplified it, I was just lazy. And now we're just gonna wait for the model to be uploaded. Okay, so now that the model is uploaded, we can see that something with the upload went wrong. So that's why we inserted these buttons here to adjust the orientation of the model and adjust the unit of measure. So now we have our card a bit longer than 4.5 meters, and we just need to put in the speed of the wind to understand what kind of situation we are about to simulate on. This is my model. As you can see, it's divided in parts. This is because I uploaded an OBJ file that already had some parts in it. Here I'm interested in activating the rotation on the wheels. So here I go and I click it on the side. The result is that I can see the wheels is rotating now. You can also upload STL files, but you don't have this feature of having everything gathered under the same object. So STLs don't offer this possibility. You can still upload multiple files at the same time and work on them in the exact same way. In order to run the simulation, I only need to decide what kind of mesh quality I want. In case I have a very complicated model with some very small part and details that I'm interested in keeping and some bigger ones, I want to go for a standard or pro simulation. On the other hand, if I have a car, for example, with no rear mirrors, no complicated wheels design, nothing like that, or if I'm interested in just analyzing one part that is quite simple, I can go for a basic simulation, which will give me results in a way shorter time, and it's also cheaper. In order to run the simulation, I just need to give it a name, highlight the speed of the wind I'm interested in too, and then set up a yaw angle. The yaw angle will appear on my 3D window viewer. I can also run a full study with multiple yaw angles at the same time, and what's going to happen is that I see all the yaw angles on the 3D viewer, so that I can see that in this case I'm running 3 different simulations at the same time, and the results are going to be gathered under the same web page. That's all. Once I click on run simulation, I just need to check that everything I inserted is correct, is exactly what I wanted to, and then I'm able to launch the simulation. Simulations ran, you do have the possibility inside your project folder to compare the runs. So in this case, I have 2 cases here, the fastback and the DriveWire cooling configuration. Both these models come from the DriveWire folder of models for car. In this case, I'm going to be comparing them too, and this is what happens. I ran 2 simulations in the same configurations with the same speed and same orientation, and here the first thing I'm able to see is the comparison between the cumulative drag that again I can choose with other indicators here. I can click on and click off the 2 models to see the differences and see what happens in both configurations. Or I can go to the slices view, for example, where I have the same slice view I had in the general simulation, but I can actually click on and click off the 2 models at the same time. This makes it easier to compare and overimpose the 2 images. So as you can see, same configuration here. I can click on and click off and see how the flow behaves in a different way. I can also do the same analysis for the acoustic power, for example. And here are the differences. Or I can actually do the same thing for the surface of the model. I can analyze front view, bottom view, back view as well, and click on and off the different models and simulations to compare and see where the differences are. In this case, the main difference of the two models was the back and the fact that in the cooling case, the inside of the car is not empty, but actually includes the whole cooling model for the car. Simulation is over, which takes normally about 1 hour, 1 hour and a half for the basic simulations, and maybe 5 or 6 hours for the standard ones. More than that for the pro simulations, but always under a day. I will receive an email with a link bringing me to the simulations directly. We worked a lot on this web page where you can actually see the results of your simulation already post-processed and gathered in a very readable way. At the beginning you have the key metrics, so drag force, lift force, exercise force, coefficients, time, area, and moments. On the right you have a little recap of the parameters you use to run the simulation. This way it's going to be easier to run the same simulation on a different geometry and make comparison. I will jump to the comparison part later during this tutorial. And here you can see cumulative drag, punctual drag, lift, everything that kind of points out interesting insights for you to work on your geometry and improve it. On the right side we have a 3D viewer. This 3D viewer is our model, the mesh of our model generated by the tool, with over-impressed the pressure coefficient, the friction, the drag, the heat transfer as well. We can also choose to visualize the pressure contours, these turbulence areas that we want to reduce in order to have less drag, or the streamlines to understand better how the flow is working around our model. We can slide through them thanks to this slider here, and we can also change the plane that we want to see streamlines on. At the bottom of our page we find a slice view of the flow around our vehicle as well. We can change the plane in this configuration, in this view as well, to have a clear idea of what is happening. And we have 50 slices on all direction that we can scroll through, and we can check the total pressure coefficient, but as well, for example, the acoustic power or other indicators as total pressure coefficients with LICs and static pressure coefficient. At the bottom of our page we have the division of drag, lift, and side force and moments by part. So in case, as I said at the beginning, I upload an OBJ with multiple parts or multiple STL files, I can see the components of drag and lift divided by part here. This again can be an indicator to understand which geometry is working better or worse compared to others. Together with the results page that we can see online, we can also download a report. This is what the report looks like, and we can use it to store the results of our simulations, for example, or to send around for other people or for the management to understand what has been done. We can also decide to share the results of our simulation just with a link. Enable sharing, we can copy the link and send it to anyone interested in checking out the results. At the same time, we can download a spreadsheet with all the numbers that we can be interested in too. In this case, you see here a quick sum up for the yaw angle that I ran. In this case is 0. If I run multiple simulations at the same time, I will see different lines here, different rows. I also have the results collected by part as well, and here I can see the heat transfer coefficient. This heat transfer coefficient can be useful again for the comparison, and I find it only here. On the 3D viewer, on the other hand, I have a view of the surface, so the heat transfer on the surface of the model. Together with this, we can also download some slice images at a higher quality, so same images I see here, but at a higher quality, and the full raw data of the simulation. So if you guys are interested in doing your own post-processing with a Purview or any other tool, you can download the full raw data and then work on them yourself. This is all for the tutorial. I will just answer some frequently asked questions now, but if you guys are interested, feel free to reach out, ask, and I'll be very happy to give you the possibility of run some test cases. One of the most frequent asked question is actually where the simulations run. Everything is based on the cloud, on AWS. Your results and your models are safe there. We follow every possible data collection and security policy that AWS offers and that AWS uses. There is no limit for the amount of simulations that can run at the same time. That's because we use cloud-based computer. And so in case you have 10 geometries, you can run all of them at the same time and retrieve the results still in 1 hour, in case they're basic simulations, and then compare them. Another frequently asked question is related to the kind of models that we can run. Again, the software we have is very flexible and versatile, and there is no constraint on the model you want to upload. We always recommend, though, to close every surface, because once the software does the wrapping around the model, you can lose some cells if you have the openings, and the software gets inside and meshes the inside of the model as well. And last but not least, make sure at the beginning of your study to focus on choosing the best resolution level for your mesh. So standard, basic, and pro simulations help you having more detailed results in case you have differences between the level of detail of your geometry. Meaning, if I have a big car and I'm still interested in noticing the aerodynamics around the mirror or smaller parts, I need a higher level of simulation like standard or pro. In case I just check one part, I can go for a basic simulation and run more tests at the beginning, and then go through a second stage of simulations where I put the model and the geometry I chose into the whole car and then simulate on it at a higher level. Thank you very much for following this tutorial today, and feel free to reach out to me and run some tests with the AeroCloud. Thank you very much. Bye.